Right. Okay. 403 to the HAZ, Mr. Nelson here. Pre-Cal 12. We're at the very end of our trig unit. I was looking at this stuff. This is kind of like, I would say that this is optional. We're kind of at a place now in trig where we've got it down to so many identities. It's not even math anymore. It's like, it's kind of like choose whatever fits the mold. Like it's, I just don't see the point of learning this stuff, but I don't think I ever used it after high school math. I don't even actually think I learned this stuff, but anyways, here it is. One day maybe you'll get so into math that, you know, trig identities will become a part of your life. So let's just play around with them. We have some more identities, okay? They're right here. I'm not going to go through each one of them. But basically, the problems in the textbook, we just have to kind of identify which identities we're using. And we might also end up using other identities from the last video. The quotient, I think it was product, and the Pythagorean. So anyway, so there they are. And so in the textbook, page 306, you know, they give us something like this. So this is 1b. They give us sine 15 degrees, cos 20. We got to put the degree, otherwise you'll assume it's radians, right? Plus cos 15 degrees, sine 20 degrees. And they want this to be written as a single trigonometric function. So you look here, you're like, okay, well, how could I do this? Well, I've got a sine and a cos. And the cos and the sine, those numbers are different. Then I have cos of that. And just looking at this, I'm like, okay, this looks like this guy here. I have sine of a number, cos of a different number. And then cos of the A, which was 15, sine of whatever was there. Okay, and so clearly it's sine of A plus B. So this, I could rewrite as sine of 15 plus 20, sine of 35. And I've just used my trigonometric identity to do that. If I go down to E, I got 8 sine of pi over 3 cos of pi over 3. So I have sine A, cos A. Where do I have a sine A, cos A? Sine A, cos A. And I've got a 2 in front. So this could be like 4 times 2 sine pi over 3 cos pi over 3. And then that's the same as 4 times sine of 2 times pi over 3, which is 4 sine 2 pi over 3. That's sad. Like, I mean, how does this help us, really? I don't know. I've never done math, theoretical math, which is what I would call this to a certain extent. Not theoretical, but like, I don't know. Man, this is just me. So maybe there's a math professor out there that's just shaking their head at me right now because I don't see the point. But I'm an engineer. Okay, let's do another couple more. Okay, here we go. We've got, this is 2 cos squared of pi over 6 minus sine squared of pi over 6. So let's look for something that has cos and sine squared. Cos squared A minus sine squared A. Boom. So I can just rewrite this as cos of 2 times my A, which is pi over 6, which is cos of 2 pi over 6, which is cos of pi over 3. Did it. Okay. I'm just pulling random problems from the textbook, page 306, and working on. We're on number 4 now. Okay, here we go. C, 4C, I've got 2 tan 76 degrees over 1 minus tan squared 76 degrees. Okay, where I got 2 tan? Okay, right here. So this is equal to tan of 2 times my angle, which is tan of 70 is 140, 152. I think 75 is 150, yep, 152. There we go. Did another one. Let's do another one. Okay, I'm going to try this one. Okay, this is D, so I'm going to do this one. This one's one where you have to kind of invoke one of the identities from the previous, the Pythagorean identity. So specifically, we need to know that sine squared A plus cos squared A is equal to 1. Okay, so we'll invoke that one. So let's look, where do we have cos squares? So clearly we're going to be down in here. And it looks like the only place we have a cos squared is right here. So I'm probably going to have to play with this one. So what do I have here? Well, I've got cos squared of A, so let's just make pi over 6 is my A. And minus 1. Okay, well, I'm going to play around here, guys, because I actually don't know what the answer is here. So let's try. 2 squared give it a shot. 2 cos squared pi over 6 minus, I'm going to replace that 1 with sine squared A plus cos squared A. Nope, I'm not going to do that. Not going to do that. What I'm going to do here is use the textbook, because this is weird stuff, guys. Okay. Weird. So cos 2A is equal to cos squared A minus sine squared A. Basically, yeah, this is why I don't like this unit. This is kind of an identity that they kind of figured out in the textbook based on other stuff. So I don't know. This is an exercise in wasting your math time, as far as I'm concerned. So that means that this is cos of 2 times that, which is pi over 3. That's all I'm going to teach here because I hate these problems. So, you know, if you want to jump into them and if you're really into this puzzle kind of stuff, go for it. I'm going to move on to combinatorics next. Bye.